going. Wait. People are okay. You got your thing? Do you have the chat open on your?
Should I open it? I'm looking
Sure.
at Facebook.
Hi everybody. Hi everybody. It's another night. Yeah.
Yeah.
I'm here with Mark.
Hi.
You know who this guy is, right?
Yeah.
Okay. This is Mark.
Hi, Mark.
Much like last night, we are going to route another board because we're in crazy board routing mode right now. We're about to send out a large batch of PCBs designed by us to be made, and I'm trying to get everything that I want made in the next month done on this batch. Yeah? So last night I routed a salmon, yeah?
Yeah.
And this night I'm routing something slightly different. I'm routing a heart-shaped board. It looks kind of like a pixelated heart-shaped board. There's people here.
There's people on. There's Mark on there.
Hi, Tanner Pearson. Hi again. Good night.
Hi, Tanner.
Hi from Vegas. We just got back from happy hour, like a really long happy hour.
That was it was like happy hours.
It was like from 3.
Happy work day.
That was like 5 hours of happy hour, literally. Yeah. I mean, luckily we weren't drinking that whole time. Just socializing. Hi, Ahmed. Hi, Jonas. Hi, Ivan. Hi, guys. Welcome to the board routing session of tonight. In just another minute, I'll start. I'm just gonna kind of like wait and see if people join in. I'm gonna move all this crud out of the way of my mouse so that I can actually move my mouse. That'd help. But I am gonna probably switch my camera down to the desktop and pull this up real quick. There we go.
Tanner says his heart is pixelated.
Ooh, I like pixel hearts. So on this this concept sketch that I pulled up, you can see there's this backpack, this lovely backpack that this character is wearing, and there's this heart in the very center of it that looks kind of, I don't know, what did you call that, 8-bit? 16-bit? What is this? Is this 16 or 8-bit?
What?
The heart.
You mean 16-bit?
I don't know.
That's an 8-bit heart.
8-bit heart, okay. Here, this thing that I'm turning on and off. This, boom, boom, boom.
Oh, hi,
boom.
Jonas.
Yeah?
People say, oh, hi, Mark, so I have to say, oh, hi.
Oh, hi, Jonas. Oh, hi, Mark.
Oh, hi.
Oh, hi.
I'm gonna go out and play some football on the roof?
Mark will totally play roof football with you if you can find a roof for him to football on. Although he probably has no depth perception and therefore can't catch football.
He just hit me in the face.
That's good. So, I'm making this series of wearables that are going to go all over my body, and the thing that's going to be orchestrating all of the peripherals is a main brain that's going to be located inside of a transparent red heart-shaped backpack, and the board itself is going to be heart-shaped, and I think I'm just going to call it the pulse board right now because it's a heart. I don't have a special name for it, like for the board that I routed yesterday, which was called the Filet-O, and it was a fish.
The backpacker?
The backpacker. No. What would you name, like, the brain heart of, like, a system? I don't know. We'll come up with something probably tonight while we're doing this. But it's gonna be, I don't know, it's like a small heart, and it's just responsible for, it has the brain, which is like the at mega.
The mega. Yeah, at mega 2560. It's got like 50 or 60 I/O pins on it.
It's huge.
It's got, more pinouts than a standard Arduino. And it runs Arduino, so.
It's thick.
It's thick.
It's a thick board. So I'm going to, basically, I'm going to break out that chip so that it stretches all the little pinouts to the edge of the board to connectors, and then those connectors are going to attach to wires, and the wires are going to go to the edge of the backpack and then to the peripherals. So it's basically kind of like the thing that focuses all of the nerves into one centralized area to the brain. I'm building the backpack this week, so if you want to grab that thing behind you.
This tube?
Yeah, that's my plastic. So this tube right here, I just got this in the mail yesterday. This is transparent red vinyl, like a fuck ton of it. Oh my god!
It's Amazon.
Thank you. At least it's rolled and not folded.
Yeah, I didn't get bent in the shipping either.
So I'm going to be making a heart-shaped transparent backpack to fit the heart board. It's basically fancy housing, but I'm gonna be able to wear it on my back like a backpack. And no, I couldn't buy one of these on Amazon. They do not exist. I looked, so I'm gonna make one, and that's okay. But first and foremost,
sorry, I'm scooting in this awkward.
Mark's being adorable.
Like, I'm rolling a chair on carpet, so adorable. You're way up inside there.
Yeah. Right. Pulse machine. It's totally a pulse machine.
I want to shout out to my nieces for getting me this for Christmas. It's my Cats shirt. It's Star Wars.
What are you?
They're AT-ATs, but they're cats because they have cat faces.
What would he do without me?
Like, my nieces know what I think would be cool, so thank you. Thank you. Why am I thanking you? What did I get for Christmas? Anyways.
Wow. Damn.
I got you for Christmas.
Damn.
That's the best present ever.
You got to wake up next to me, mister.
Yes.
Like
every day's Christmas.
Exactly. That's what I say.
All right.
Okay, so we're gonna route this board. I'm gonna open it up in the AggleCAD. Wait, so I'm gonna switch after I open it. Then I'll switch down to my desktop view.
And what did AggleCAD do today for you?
Oh man, I have to say this. So I routed the Shibon Filet-O salmon board last night, and I posted it on Twitter, and it was just like. Here, let me show you. Is it open still?
Screenshot? I think I'm phone.
No. I have it open already.
There it is. Filet-O.
Okay,
Filet-O.
So no, I have to switch the thing.
Oh, you have to throw it up.
Wait. No, I have to go. Oh, there it is.
I don't understand things. All right.
Okay, this is the board I routed last night. Those of you who are here for that, thank you for keeping me company while we did this. Mm-hmm. But up until about midnight last night, over the period of 3 hours, I created this delicious piece of fish. This is a cross section of salmon, and I tweeted a picture of it, and Autodesk EagleCAD, the owners of EagleCAD,
the new owners of EagleCAD,
the new owners of EagleCAD, they were nice enough to retweet a little blurb about this board and what it does, which was really nice. Cool, so I'm glad that they recognized my salmon cross section as art, and that makes me happy. So thank you, EagleCAD and Autodesk, for doing that. That was nice of you. I feel like a real thing.
It doesn't exist until AutoCAD's like, yes, we bless this with all of our
bless your
AutoCAD power.
They blessed my fish.
Bless you away.
So I'm going to be making a heart, and I've already, kind of like yesterday, did all the hard, annoying stuff that isn't very exciting, so that you don't have to watch me do all of that. But like I said, oh man, that's not what I want. That's what I want. I'm going to really quickly navigate to that file before I switch back down to the desktop view, which is what I'm doing right now. Blah, blah, blah. Oh, wait. So this is Shibon. PCBs.
Tanner says Mythbusters didn't do you justice.
Oh.
Maybe they'll come back around or something.
I doubt that.
Maybe all those other losers won't work out. I'm kidding. I like those guys.
I doubt it. I don't know. I don't think anyone got me. That's okay.
There'll be a new show.
I don't even get me.
With quirky salmon fillets live on television.
Wait, where did my salmon board go? Is that actually called Dick's?
Did you call it Dick's? Was it the one you just were running?
Yeah, what is this called? Oh yeah, that's Dick's.
She called it Dick's.
I don't know why.
You must be really into sporting goods.
Yeah.
Anyways.
You're a funny one.
I'm trying.
Dear pizza.
All right.
Okay.
Make sure that's saved.
I did save.
Okay,
wait.
Just.
Okay.
You know. Backups.
All right, I'm gonna close it. Save it.
All right.
I'm Xing out of it. I'm gonna rename it eventually, but probably not now. Okay, so I'm opening not Dick's, but the Shibon Heart board, which is here. This one actually has a proper name that isn't like Dick's or Rage or Vaginas or whatever I name tentative boards that don't have like titles yet. Apparently Dick's. Jeez. It's like I'm 12 or something.
Yeah, if I go use the 3D printer, like half the files that are on the 3D printer are like, like they're all the same. They're like revisions of the same thing, and they start out with like robot arm leg 53, you know, and then the next one is like dicks. This sucks. Dumb. Stupid. Why won't this work? Please print now. And it's like, and yeah, she fills the card up with like, you can like, see the frustration build in each revision, and you're just like, oh,
yeah.
I'm not gonna. So you're at the dicks phase with this board, I guess.
Yes.
Is that because the DXF wouldn't come in?
Yes.
Yes.
There's some dicks. I couldn't like the DXF. Like if you import a DXF file into EagleCAD, which it doesn't import unless you get rid of all of the curves. So if you want to make the edge of your board a custom shape that's not a rectangle, which I do for all of my boards, you can make a fancy curved board, but you have to originally in the beginning import a solid line.
They have to be straight lines.
Straight line bullshit outline of your board, which is really aggravating.
Is it both Autodesk Fusion and Adobe Illustrator both didn't import properly?
No, Fusion 360 will import a DXF with the curves, but EagleCAD will not import a DXF with curves, so that's something to note.
Well, but if you exported from Fusion with curves, did it import into...
No.
And they own the same program now.
They're the same company.
Wink, wink, nudge, nudge, AutoCAD, Eagle. But Adobe Illustrator, Adobe has no interest in fixing that ever, because it's been in there for like 7 years since I've been trying it. Like, curves do not work if you try to do something in AI, export it as DXF, bring it into Eagle. It just don't work.
I don't think it's Illustrator at this point. I just think it's some voodoo magic.
Well, I know Illustrator messed up because I've sent a Illustrator file over to an actual laser cutting place, and they were like, "What is this?" It was a DXF. They're like, "What is this?" It was like, the curves are gone. I'm like, "Oh."
Do you want to get me more water?
Kind of.
Do you want to get yourself more water? Oh my god, you still have water.
Yeah, because I'm like sipping and chilling. You're thirsty.
I had 2 martinis.
Here, let's get you some water.
Martinez.
You want a martini?
No, no. Please don't poison it. Wait. Do I have to go and supervise you? What are you gonna put in it? Mark? I don't know. Okay, so this board that's down here, those of you who aren't familiar with EagleCAD, which I don't think is anybody at this point, I think all of you guys are familiar with board routing and Eagle and whatever. You have your schematic and then you have your board file. This is the schematic that that represents what it is I'm trying to achieve with the pulse board. There's these 2 banks here that have an A through A through L sections. That's the actual at mega and all of the pinouts for the brain. All of these little nuggets up here at the top, are neopixels. They're RGB LEDs.
Your arsenic.
Thank you for my poison.
You want me to sip it? Do you want me to be your taster?
Yes.
Right.
It's not vodka. I hate you. I don't.
There. I'm just not. You have doubts.
Why would you want to be with me if I doubted your whether or not you'd murder me or not? Are you trying to murder me?
No.
Do you believe that I should not trust you?
You're the one who doesn't trust me.
I trust you explicitly.
You said, "Are you going to put poison in it?" And I walked away, and I'm like, "Why would I put poison in it?"
I was teasing you.
All right.
Okay, so there's this bank of neopixels up here at the top.
Keep going.
There are 14 of them on this board that go around the back perimeter of the board, and they're going to light up and pulse to kind of like illuminate the inside of the backpack. So that's what these are responsible for. But I don't know what this is. What is this, Mark?
What's what? That is the section of your chip that has power and reset and the crystal. So when I made the Atmega chip is so big, it has so many pins,
so big
that you can't fit a single chip in your schematic and then still route stuff in like a paper-sized page. So I broke the chip up into 3 sections. Eagle lets you do that. So this is my Atmega. I designed this.
Mm-hmm.
This is my Atmega schematic bodies, and there's 3. You can see there's section A, B, C, D for those ports,
Mm-hmm.
F, G, H, whatever for the other ports, and then I just separated out the whole power section as its own thing, and you can just add the reset wires and your crystal and your power and your ground all as a separate thing, and then just focus on your ports. Yeah?
Yeah.
Okay.
Then there's a bunch of capacitors. I'm guessing these are bypass caps.
Those are the bypass caps for the something.
ISP header right here. Blah, blah, blah. I gotta rename some of these things. Heartbeat, I don't know what the fuck that's for.
On the this is reused. No, this is reused from another board I did, and that was just the LED, the pin 13 LED.
Okay.
Or it was it wasn't pin 13. It was I was flashing a light on that board, so I called it heartbeat because if the program is running, the light was flashing. If the program stopped for some reason, there'd be no heartbeat. So that one I needed to know that it was always running.
Debug serial.
That was a extra port. You can get rid of that.
What? I can get rid of this?
Well, I was using a second port for debug on that chip. This chip has multiple serial ports. The Arduino only has 1 serial port. This chip, I believe, has 3 serial ports for you to use. So on this particular design that we copied this from, it had a second serial port just for debug.
So I'm getting rid of it?
You get rid of it.
Okay, so I'm going to select the debug serial, and I'm going to murder its face. I'm going to right-click and go delete group. It's gone.
Right. So the other one is a power connector.
What's a wavy?
That's a fuse.
What?
That's called a polyfuse. So it's a fuse that blows, and then when it cools down, it heals up, and it's a fuse again.
It's a self-healing
fuse. So you don't have to replace the fuse if it blows. So you can leave that on there if your power comes into this one.
Okay. And
that way, if something gets shorted, you won't catch on fire because it's on your back. That would be awkward.
I don't want to be on fire in Tokyo.
The connector is... No. What is the connector? That's a PH... I think that's the connector we use on the other board.
Yeah.
For your speaker. So it's the same. It's a small power connector. I think.
Okay.
Is it?
No.
Oh, you have to look at the layout. Okay.
It's way over there alone. It's like alone away from people. That's like the me of Recess and why is my mouse not working?
Yeah, it is.
Oh man.
It was moving. It's just not responding.
It's only going in 2 directions.
Oh, wow.
Oh, there we go. Nope, it's still only going in 2 directions.
Did your mouse get clogged? Look at the bottom.
I hate when my mouse gets clogged.
Dirt can get in there. Is it better now?
Yeah. I hate when dirt gets in there. Wait, what the there's like a... I need a mouse pad.
Yeah, you should get it like a good...
A not shitty mouse pad. Whatever. Okay, so... Everything's there. If I switch over, if I click this little icon up here at the top and go to the board view, you can see I already imported the outline of my heartboard, and luckily it didn't have any curves, so it imported fine from just a plain old DXF. Didn't have to screw with it or anything. And you can see my LEDs are on the back side, around the perimeter. The big ass Atmega chip is in the middle. I don't have any connectors going to any of the pins, so that needs to be added to the schematic. So none of the pins...
you need to put in the connectors that you're going to want, and you're going to need to put in the serial connector from the other board, the 6-pin.
Yes.
So you're going to need to figure out where you want to put it.
So my question for you is, what connectors am I going to use at the edges of my board?
If you just want to go simple, is go all with those 0.1 inch.
What is that?
The ones we used on the other board.
What other board?
The one last night.
What?
The 4-pin things.
What?
They're standard headers. They use this
the right angle.
Yeah.
So right angle male headers, or right angle male headers, right.
Yeah, or you can go with the JST connectors.
What's that?
They look like those Molex connectors.
Where?
That we use on the other board, on the lymph board.
What is that? You should get one so I can see what you mean. Oh, and that other thing I can show. I'm gonna look at the chat. Oh man, people are talking. Hey! Hi, Tony. How you doing? You should, Tony. You shouldn't be on watching this. You should be.
You should be partying.
You should be partying in where you're at. You're on an adventure. Yeah. You should be like doing disco in your hotel room or at a bar or something.
All right.
Polis Squalus, hi. How are you doing, Polis Squalus? How are you doing tonight? Welcome back for the second round of board routing roulette. Hi, Ahmed. How are you doing? Hi, guys. I'm so happy you all are here. Everyone says hi, Mark, because everyone likes Mark.
Oh, hi, Mark.
Everyone loves Mark.
I should get one of those wigs.
What?
Like the guy from the room.
No.
I should get a wig that he had, the Fabio hair.
Ooh. Noodle says you need to make your mistakes with this one so you can make him a bigger brain. I agree, Tony. Noodle, next bowl of ramen brain, because Noodle's brain looks like a brick of ramen, is going to have the big at mega. And I can make all my mistakes with this one so that when I do redo his brain, I don't fuck it up there. Aw. But yeah, Noodle's gonna have a bigger ramen bowl brain. Maybe this summer. I don't know.
Okay. You said what connectors?
Yes, what kind of connectors?
So this board is has Molex connectors on it. They're, instead of 0.1 inch separation, they're 2 millimeters. So they're metric connectors. This has Molex. I'm proposing that you use the JST.
Yeah. And
they're the same pin spacing and everything. They're just cheaper. Yeah, but they plug in. They have like this as a cable.
Yes.
So that, like, these don't come out. They're locked in. They're hard to remove. And so if you don't want it when you're moving around, if you want stuff coming loose, that's a good option. And they're small.
Do they come in different, like, numbers of pins?
Yes. Did I give you my JST library for CAD?
Did you?
Which I already made. Well, is it in there?
Okay, so look,
I think you do. You have a Con JST. Yes, open Con JST. You have a 2-pin and a 3-pin, and if you need more pin and 4-pin, you need more, I will make you more. I'll design a 5-pin or 6-pin or 8-pin, which I don't usually use, but if you need that.
These are more than 4 and 3 and 2. These are like 12.
Those are Molex. That's my Molex set. Do you want to use the Molex set? Because I have all the Molex connectors. You're just doing one board? Go with Molex. I have the crimped wires and everything. So.
But I don't think I need like that many at once. I think.
What do you like? What are your? That's the thing, is what are your sensors doing?
Let's go back to my art.
Sensing. You can't have a serial port on everything.
I don't actually know yet. That's the thing. I only have one. This brain, as of right now, is only powering one peripheral, which is the crotch piece, the salmon, the beatbox, the filet-o. That's the only one I've designed so far. I anticipate over the period of like the spring, summer, there'll be more, but I haven't done them yet. So I'm just sort of like deciding like, okay, to these parts of my body here, I even drew them there. Bam. Okay, head. I'm like, all right, I'm gonna have something on my head. I don't know what, but there will probably be something. Right. Nips. I don't know what that means. Neck.
I do.
Arm. Wait, why does it say R-L-L-R?
Our arm, left arm, left thigh, right thigh. I
got those backwards. That's okay. It says right, and then I'm retarded.
Stage left or house left?
Both. Thighs, buns, pelvis. So I like all my body parts are covered. The only one that I've actually designed something for is the filet-o, which is the pelvis. So somewhere towards the bottom of the backpack, there's going to be pins coming out through the bottom. Going to that. Everything else, I just want to like in this design, there's 4. So 1, 2, 3, 4. Do you think that is enough?
Well, so you need to kind of know what data you're sending over these things. Like if you're just putting digital lines, right? A digital line by itself isn't a serial port or an I2C bus or anything. So if you have a device up on your neck. That's I2C.
Yes.
Then how are you going to get that information down to the board if you don't have an I2C port available? It's just digital pins. So are you gonna?
So should I add that? Do I add an I2C port for the top and
you
bottom?
only have one I2C port on the chip. right? And as we learned when we tried to network our Delta robots together,
God.
you can't get more than about 1.5 foot of I2C wire before you start to have problems.
Yeah, you're right.
Because that's a bus. It was not made to be external to something.
Antenna! Yeah.
So your options are you just run 6 or you have ports. I think you have that many ports. Is run 8 wires, 8 data lines.
Okay, so my hypothetical question is then, can each of the peripherals have a brain, and then the heart board just run power to everything?
Well, then you would communicate. How do you communicate to them? Like, if you're just putting power out, yeah, but you're not getting data back to the main board. It defeats the reason that you have that processor with so many pins on it, right?
Say I just want to get data from all the individual peripherals and store them or read them or log them.
But this is what I'm trying to tell you, is that data
needs to come through on it.
If the sensor that you're using spits out serial information,
yes,
then you need a serial channel.
Okay.
The problem is that the chip has 3 UARTs on it.
Okay.
3 serial channels, and you're already using one for the crotch.
Yes.
You can't network a serial channel for coming in. You could, like on DMX for our robots.
Yes.
You can have one master and many slaves, but in this case, you have all of these. You wouldn't call them masters, but they're sending information to you. So you would need a separate UART for all of those. So you need a way to multiplex, or I would just propose that you run 8 wires plus a ground in your power, so 10 wires per area, or allocate that. So a port each, a port on the chip each. And worst case, the data you're getting, right? Let's say it's a number, and you get a number from 1 to 256 or 0 to 255 every second, right? That's not a lot of data to transmit every second.
Okay.
So you bit bang.
Bit bang bang.
Bit bang means that you're going to manually toggle some data lines to move that data over the wire.
Bit
so
bang.
It doesn't need to run at megabits per second. It runs at bits per second, right? But the data gets over, and then you can just write code that loops through that.
Okay.
Okay, so it's like an old-fashioned, the way we used to do chips back in the day.
The way we used to bang bits back in the day.
It's called bit banging because you're gonna you can do what a UART does, which is put one signal over one wire, but you have to have an algorithm protocol in your chip programming that knows how to deal with that bit stream coming in, right?
Yes.
So you're gonna have to do that manually, whereas the serial thing that's built into the chip is built into the silicon, and you only get 1, 2, or 3 of those, right? So my point is that you can do that in code. It's just going to be a lot slower compared to what the chip is able to do, but you can do it. So, and there's probably some just easy things that you can come up with. But if you run 8 wires to each zone, you can probably do some pretty clever code hacks that move the data that you want over. You wouldn't be doing video or audio over those long wires, but you'd be doing, if you're just measuring heartbeat information or pulse or heat, that's easy information to transfer over doing it the hard way, doing it manually in software. So
yeah, I need to add the pulse sensor to the salmon.
Oh, you need to update that?
Yeah.
Do you have a pulse sensor?
No.
You need to get that one on Timby.
Get it? I was gonna get the one off of Adafruit, so I need.
Oh, do they have a pulse sensor?
Yeah.
Oh, it's probably similar. Okay.
Okay, I need to order it, and then.
Do you want to integrate it onto the board, or do you want to just buy Adafruits and put it on, or you just want to lift her schematic and put it into your schematic?
It's an external thing, so I just need to put whatever the pins are,
right,
and then add.
Well, that's what I'm saying. Is if it's 8 components on her board, then just take her schematic and integrate it into your schematic.
No, because it's an external thing. It's a sensor. It needs to be put on the skin. So I'm not going to have a separate board. So I'm just going to buy it. And
you're going to put that sensor in one of the wires in.
I just have to add it to
All right, that makes sense.
So that needs to go on the salmon. So it's kind of, it's closed individual thing. Like the salmon has its own brain and it's running as its own individual organ. It just needs power, which I kind of want to run from the backpack, right? So...
Right.
Well, I'm not really quite sure what I want the heart to do. I just want to make sure that it has some
right?
capacity to
so
do it.
The other downside of all this is you're gonna run 50-something wires onto this tiny little heart.
Yeah.
Like your connectors aren't gonna fit. So you're kind of like, what are you gonna do? You could just put the holes like that board uses, right? You can the pinouts, see the holes on the bottom, the pins. You can just put those and not use connectors, but literally solder in wires into each hole as you need them, right? Yeah. And you can put those holes pretty close together.
Then I can do that.
So
that's fine.
So you won't have the space taken up of that, but
that's
you can maybe wedge those in.
I like
or
holes.
Just limit yourself to 4 signals per zone. And if you need more
holes,
I don't know. If you need more, then either, spin the board as you go, maybe.
Can I get like 4 data holes and then a power hole for each thing?
Yes, and a ground, yeah. So 6, that's a 6-pin connector.
6 pins for each area.
Yeah, that's not a bad compromise. I think you could do a lot with 4 data lines per area.
Okay, so let's do that. Done.
All right, do you have Con Molex? Did I give you that?
I don't have a 6-pin
No,
Molex.
That's JST. You don't have Con Molex.
Fuck. Get it.
All right, I'm going to get you the Con Molex.
Thank you.
Oh.
I love you. All right, let's go back to the chat and see if anyone's talking to us. You is of the 2 smartness to me. Oh, thank you, Tanner.
What?
No. I try to be the smartness some days. Right now, I'm just kind of coming down from happy hour buzz. That's amazing. Like, I had that martini at like 4 or 3, and it's like going on 10, and I still
nursed that second martini all night.
True. So I had 2, and they were good. They were dirty, and they had those Gorgonzola stuffed olives, and they're delicious. And they had the little ice shards floating on the top. Although the ice shards did not last very long because it was quite warm outside today.
Yes. That's
okay. Disappointed there are no ears over bun circuit. Ooh. Wait, what?
Ears? Ears.
Bun.
The head.
Oh, I think he means like a bunny. I don't like bunnies. No. Sorry, Polis.
No, bunnies must die. Sorry.
Bunnies must...
All right, I gave you a thing on the messages.
What?
I gave you the library over message.
Yes.
So go into your message thing.
Vigray says drunk streaming again, I see.
Yes, that's the only way to stream.
That's the only way.
How would you do this sober? I don't understand.
Make anatomically accurate heart with extending arteries for a small distance. Probably like cliche though. We actually considered that, Polis, or like Mark suggested it when I was like first kind of scheming of making a heart board. He's like, put an actual biological heart circuit board inside of a big like symbol heart backpack, and I was like, no.
Did I say that?
You did, and I shot the idea down because it's not what I want. He doesn't remember, so I came up with that idea, and I shot my own idea down.
Maybe before you shot it down, I was like, you could put a slit in there, and you could punch your hand through it and pull that heart out, right? And it's all bleedy, and it just pumps, and then it dies.
You're dumb. Dumb. Dumb.
All right.
Too many Kali Ma movies.
Kali Ma?
What are you trying to get through the signal? I have no idea yet. It depends on the...
She has no idea.
No idea yet.
So...
I might not need it for the Phileo because that's all kind of... all that shit's located on the board, so it just needs power. But other things, like if the sensors are closer to... need to be located closer to the chest, then it makes sense that those sensors are connected to the heart versus the area of the body that things might be actuating on. So where the crotch kind of is self-contained and the sensors and the things that are activating are all inside of the panties, other things might not work that way. So I'm just kind of like leaving myself options for whatever it is I decide I want to do later on in the future. You know how that goes. I know you do.
Hi, RT Tolly.
Hi, RT Tolly. Ooh. Woo.
I think, like, once you get past the sensors and where they go, like, a lot of the areas that you're doing, you're probably going to be sending out LED feedback.
Yes.
So, as long as you have a path to get there, we can wire in more, neopixels or whatever.
Sorry.
The stuff.
So this is going into documents, Eagle, libraries, and Con Molex is going into libraries. Okay, so now that that's in there, I'm going to X this out. I'm going to click library, use, Eagle, library, Con, Molex, open. It has been added. And then I think my what is this? Concept sketch says that I have 1, 2, 5, 6, 7, 8, 9 areas. So I need 9 6-pin Molex headers.
Yeah.
Yes.
I hope I gave you the right one.
Really?
I have 2 Molex libraries. One I don't share with a lot of people.
Would you share it with me?
You need to sign an NDA. All right. Just look. I'll give you the other one.
I'll give you a Molex.
Yeah.
Con Molex.
What's in there? Ah, crap. That's my Minifit Junior library.
Go.
So,
Fuck.
and tell everybody what a Minifit Junior is.
Don't even.
Go look it up.
Mark's considering buying a Pico Brew because he's dumb. Tell him not to.
I was, and she talked me out of it.
Jeez. Those martinis were really fucking good, though. I had a chopped salad and I had potato skins for dinner, and I'm still hungry. But the dirty martinis were swell, and we never went to Fry's because we were there late.
Yep.
With people. My mom, who we were meeting, we thought we were just meeting my mom. She invited like 10 people, like unofficially, and they all showed up. So the bar, like we took up the entire bar with people, and I was just kind of like, we just sat there forever. Yep. So I was back at the same Victoria's Secret that I was at on Sunday. Yeah. Well, across from it, at least. Ooh, Mark sent me another file. Do I have to sign an NDA?
Yeah.
Loser. Wait, this one says ROBOHEMIAN.
Yeah, it's the ROBOHEMIAN.
I'm gonna put an NDA inside of you. Okay. Ready?
Yep.
Are you ready for it? Close all of these. Jesus. I have to know. Are you ready for data? Library, use. What is it?
ROBOHEMIAN.
Where?
Ours.
ROBOHEMIAN connectors.
ROBOHEMIAN.
Open. Okay, so I'm going to add my ROBOHEMIAN thing. ROBOHEMIAN connectors. Oh god.
Right. Check out upper. Look at Molex Microblade 5-pin or 6-pin.
You almost smell kind of like a.
What? Like Italian.
Like
sausage. Okay.
What?
Look, do the 6-pin. Open that 5301-06110.
This one?
Yeah, open it. What's in there?
Ah.
It looks like that, and it looks like that.
I don't want the thick one.
That one is a vertical. You plug in this way, and the other one is this right angle.
I want a right angle.
Okay. All right. So that is the right angle connector. And then
I need 9 of these.
Rotate it. And you're gonna just put those in the open area, and then you're just gonna run flags over to what you want.
So
don't put them near. Yeah.
2, 3, 4, 5, 6, 7, 8.
9. Is it you really got 9 areas?
Mm-hmm. You know how many areas I have. Okay.
All right, you're gonna need to rotate and mirror those because you want pin 1 on the top.
I hate everything. Okay.
Just rotate and then just flip them. Well, rotate them all at once. But, yeah, just put them down. One on top.
Okay.
All right, now
Mirror.
Mirror.
Better. Are you happy?
I'm extremely satiated.
Yes.
All right,
Good.
your pin 6 is always ground. So why don't you just bring up a ground, copy a ground off your hardware.
Okay. I know how to do it.
Then put yeah, on every pin 6.
This is going to be an easy board, unlike the one from last night. So this is probably going to...
Wait till you have 9 connectors with 4 wires each and tell me how easy it is.
Shh. Okay, fine. This is going to be hell.
You're going to hate this once they come up. You're going to see your board's going to be larger than you thought.
Shh. Okay, don't do that.
What?
I don't know. Everything.
Just... All right, pin 5.
And it's going to be the heartworm board. It's going to have wiggly traces.
Pin 5 is always VCC.
It's always cancer.
So copy VCC.
Yes. Oh. Oh, it's a circle?
It's the circle. I use circles because I like circles.
Mark like circles.
Yeah. Yeah.
Shh.
I don't like sideways.
No one likes you.
What? What did you just say?
Nothing.
Why doesn't anybody like me?
Because you don't like sideways.
Why am I not likable?
You don't like things sideways.
I like something sideways.
Like what? Okay, done. Now what?
All right. Now your other 4 remaining signals are your signals. So you get to decide where those are. Now, if you want your board to route easily, look at the chip on your board, right?
Yeah.
And look where the pin numbers are, and then you're going to route signals in a star pattern out, so you're not crossing anything over, and that'll make it easy to route.
What is this?
So, what is what?
These. So you told me I needed. What?
What is that? I don't know what that is. What layer do you have turned on? Zoom way in. It's probably the paste layer. Zoom in more. Keep going. All right, move it, slide it. That looks like. Go into layers, turn it off.
Why?
I think you just have extra.
Better.
What was that?
I said all. Oh my god, the connectors are so big.
I told you.
Fuck.
That's the smallest you're gonna get on a connector. And that's only like. That's an 8-pin. So it's smaller than this. So your heart is like this small. That heart can be totally bigger, honey. Make it 100 millimeters. You can do a 100 millimeter board on Seed for $5.
Give me the calipers. I love you. Give me the calipers.
Get the calipers.
Calipers. Thank you. So you're saying 100 millimeters, really?
Yeah, that's so. Seed Studio. Their special is 100 millimeter by 100 millimeter board.
That's that big.
Well, you can get up to that big.
I don't want a board that.
No, but it's going to be heart shaped, so you're going to be chopping a lot off.
That's fat.
But anyways, Seed Studio has a 100 millimeter by 100 millimeter board for $4.99. You get 10 of them, right? In any color you want. And what was the other thing I was going to say? Except their shipping is like $20. So. So for $25, you get 10 heart boards.
90.
So you may as well go to that size, because when you get beyond that size, then the price gets really squirrely. So that's their special. So go for it.
All right, fine. Okay, so this was what the salmon looked like. Remember me saying that you can't import a DXF with curves, so you have to turn it into straight lines. So this is what that became. This is a salmon pre-curve.
Thanks, Adobe.
Yep. All right. Where's my heart? Sadness. See, I even named these things. This is sadness.dx.
Sadness.
God damn it.
Wow.
Okay. So I'm going to re-import the thing. Let's make this
with 100. Right?
With 90. Bam. So this is now 90 instead of, it was 70 before, so this is not that terribly much bigger. Are you serious?
Yes.
95.
You want me to get a 100mm board for you and to show you so you can hold it?
Hold me closer.
Let me see if I can find the 100mm board.
Tony Danza. Okay. So this is 100 by 80 to 83.
This is 100 by 100.
That was big.
That's not big. For your backpack, remember, you're taking the shape down and rounding it, so it's actually going to look smaller. But I would propose that you go to the full 100.
Okay, if the chip is thick, then the board can be thick. Full 100.
I can find the board that had that chip on it.
Alright, so I'm going to re-export this DXF because I hate everything. This is how you import a DXF into Eagle, which is something that it was like a big deal when Jeff taught me how to do it. It was a big deal when you taught me how to do it again. Everyone's like, it's hard. Hard. Because it doesn't obey you. That's why it's hard. Okay, so I'm going to save this as something cheeky to my desktop. Give me
That doesn't. Put your thumb over that. We're not going to advertise
what this is from.
Who that customer was, okay? Alright. That's 100 by 100, and that is the chip that we're using because it came off of this design. So that is that. So
it's pretty color.
Your heart will be, that's a good size heart.
Okay. Ooh.
And we know it'll fit now. And that has the big Molex connectors on it. So yeah.
It's pretty. It's a cracker.
It's right.
You can put transparent tape over.
I know, I was like, that didn't Greek anything out. So.
Okay, so I'm going to save this as a DXF file. What should I name it? Give me an inappropriate word that exudes frustration.
Achy breaky.
Crotch.
No, that's it.
Achy breaky.
Heart.
Dick.
Achy breaky heart.
Dicks.
Achy breaky dicks.
Achy breaky cunt. Achy breaky.
Oh, arms. I'm gonna go reset the printer.
Oh yes. Okay. Achy breaky lobster. Don't. Okay, you want to save everything in one scale to 1 in millimeters. You click OK and it will save it. And this is again 100 millimeters by 83 millimeters for my heart. Okay, so I'm going to go back into my board thing. I'm going to turn everything off except for the dimensions. You're going to see the original heart. I'm going to delete this because I'm no longer using it. So bye, old heart, tiny heart. You're not big enough for me anymore. Now I'm going to do the fun thing, which is importing a DXF into Eagle, which for some reason has always been a point of contention throughout my entire board designing career now. But you go to Run ULP here, and then in your ULP folder there should be a thing that says Import DXF here. That's that. You click Open. I'm going to click Lobster, which is on my desktop. I think that's where I saved it. Yes, so I'm going to click on Lobster, DXF, Open. I'm going to put it on the dimensions layer, and I'm going to make sure that I've selected metric and not imperial, because that's how cool people design things. They design them in millimeters and metric. And I click OK, and a thing should pop up with numbers. If you see lots of numbers, that means that things are actually going to happen, and that's a good thing. You click Run, and you should get a thing popping up, which there's a thing. So I'm going to change my grid size so that I can actually stick this where I want it. 1 millimeter with like one millimeter meter. Looks good. So I'm gonna select this whole giant ass heart and I'm going to move it.
I would center it.
Shh. Wait, what?
Center it on the X.
What X?
On that plus.
Yeah.
Center. Make this at the center of your board.
There?
No, you move it down.
Why?
Make that plus the middle of the board. Then when you're doing symmetrical things, you have a number as a reference.
You aren't allowed to do that.
Yes, you are. Oh, you aren't. That's because you're using the free version of Eagle. Ah!
Shut up.
If you pay for it, you can do anything you want. Okay.
You're a dick.
I know. So, sorry.
I don't have any money.
I forgot the poor people use this tool too. Draw a box, starting at that, and then put your thing in that box so that now you have a reference.
No one
Not
likes
that box.
What?
Like do a line, 4 lines.
What?
If you want to get that thing even on the axes, is draw. There you go. Right click to get the right thing. No.
Shut up.
There's an easier way to do this.
Nobody likes you, Mark.
What?
Nobody likes you.
Don't give me a complex.
What? You aren't complex.
What?
I love you.
Just do one axis at a time.
You did. Oh.
Oh, look at that.
No. No. I've got this. There we go. Okay. That's good, right?
It's one more.
No.
That's good.
What?
That sure. Go for it. It doesn't matter. That's not going to hurt anything. So. Is it truly 100 millimeters?
Yes.
Okay.
It's 100 by.
The width is 100.
Yes.
All right.
Which
so it's your center.
It's not. It's not on it.
Yeah, it's because whatever generated it didn't put it on the same grid. So it doesn't matter.
Okay.
It's fine. Okay.
I've got heart.
Yeah.
All right. I'm gonna turn everything on now. All. Okay. So there's. Yes. Check that out.
All right. You're gonna throw your connectors down first because those LEDs need to work around your connectors.
But the LEDs are on the back.
Yes, but those are through-hole connectors.
Oh shit!
So put your connectors first, and then put your LEDs underneath them.
All right, so I'm gonna stick these kind of. Shut up. Kind of like under. Yeah.
Sure. You weirdo.
Don't talk dirty to me like that. No one likes a nasty peeper. Noodle. Noodle's like, what? That's my reset button.
I'm gonna check your chat for you.
Don't touch anything?
Don't touch anything.
Okay. I'm just moving things inside of the board. Oh god.
Oh my god. RT Tolly says that he's a close friend with an artificial heart, and so we should stay away from him for his safety.
What? Why?
Because you'll give him digital heartworms.
Oh.
Handsome Rob wants to know what he missed today.
Oh.
And how did yesterday go? Yesterday went fantastic.
Did it?
And you can see from Sarah's Twitter feed, if you twit, what happened. Those connectors are reversed.
What?
Flip them around. The open end is the other way, so just 180. So that went handsomely. And then today, we just got started, actually, Handsome Rob. So Sarah is doing the heart board, which is the second circuit board, and that's the one that goes on a backpack on her back, heart-shaped. And so she's putting connectors and LEDs on it right now.
Oh god.
And Vibrate says Tony's great with names. What did Tony come up with?
Tony, what did you say?
Oh, I don't see any new Tony names, but yes, Tony is the name guy.
Tony.
Tony has nothing for this one.
Tony!
And he's going to bed. Have fun with the board. Good night,
Good night, Tony. Enjoy your trip.
Enjoy your trip.
We miss you.
You're going to love it.
I miss the ox. Oxen miss. Oxen missing. Okay, that one goes. Sure.
You can't go up past the edge of the board.
Yeah, you can.
Well, no. They're gonna hang over the board, don't you?
Yeah.
Do you want that?
Yeah, because I want my LEDs to go on along the edges, and that's important. Don't question my cake.
Non-standard circuit board design.
Do you know who you're sitting with?
Yeah, unfortunately, yes.
Honey.
It's starting to come in.
Do you know the power of the fully operational battle station?
Raptors. You know those in the right order, right?
Fuck if I know. I'm just...
You need to, like...
I am a nightmare.
Look at the number on them. They need to kind of go clockwise in order. You're going to fix that next.
What? They're fine.
Does it say J1, J2,
J10, 9, 8, 7, 6,
5, 4, 3, 2. Oh, and 1 is your other connector.
Yeah.
Where's that connector going? Wasn't that at the bottom? That little 2-pin JST connector?
What?
And what's that for?
Wait, what?
That's your power. But you're getting power from where? How are you powering this board?
With a power supply, like a circle.
Okay. A circle?
Like a rechargeable USB thing.
That's what that connector's for then.
So it goes...
We could put a USB connector on it. Would that be easier?
No.
Then you're not fiddling with... Alright.
No.
You need a USB connector?
Yeah.
Do you have it in your library?
Probably
I
not.
don't think you do. The USB connector that Seed gives you, it will be fine. So go use that one.
Okay. That's not bad.
I do that constantly.
What do I do?
You add part.
But I have to get rid of the part.
No, you just put it next to it and then delete it. So just add part. Seed connector. I think there's multiple of this connector, so we have you just need to slow it down. Scroll down.
Blackmail. Does that say blackmail?
It's a blackmail connector, not a description of a human being. Yellow females. I like yellow females.
Okay.
Long blue. I like long blues.
You get that enough at work?
Yes, I get enough long blue at work.
What do I do?
You are doing, okay, micro USB SMD, right?
Uh-huh.
Now you're down to like a couple choices.
There's two.
You want, no, the one above it, the ZX62.
Oh, uh-huh.
That is the connector you want. That's a standard USB micro cable. And so go put it near that fuse thing down there on the right.
This?
Yes.
Okay.
All right. So let's modify this. So get rid of your J1. All right. And now move the connector. Oh, you're going to have to just move the ground out of the way temporarily. And then, rotate the connector and mirror it. So mirror and rotate. Right click, then middle click. There you go. Middle. There. All right. Now put it. Line that wire on the F1 with your V bus pin.
Bus.
There. Yes. Okay. Now put the ground, that little orphan ground, on your GND pin. And you now have a USB connector for your thing.
I don't need anything else?
No.
Really?
No, I think
what about Shield and ID and DD?
No. You can hook the shield to ground if you feel inclined. So go ahead and do that.
Move this whole thing up because it's. Okay.
Yeah, you should be fine.
Yeah. Do I hook shield up to ground?
Yeah, just add a ground to that. Copy it.
Okay. All right.
There you go. So that just brings power into the board using a USB connector.
Mm-hmm. And then that goes here.
And then, yeah, put that in that. That's going to be the top, right?
Yes.
Flip it around. So that's coming into the top, not the bottom.
I want it to be in the heart nipples.
Oh.
Or the heart crevice, not nipples. The heart. The nipples of the heart. The heart. The crevasse. The crevasse of the heart.
All right, so now, get your LEDs where you want them now.
Should I have these things sticking off the board? What are they? What do they look like?
They're these white connectors. So see how I have the front flush with the board?
Yeah.
That's how they are. If you overhang them, they're not going to have as much support, and so they might break easier. So there's a little bit of support there. I would line them exactly up with the edges.
Where's the actual X
on
on these?
The X is on pin in the middle. Yeah, there you go.
No, it's not.
Is it?
No.
It might be on pin 1. I used to do that.
Okay.
That's not, not the best practice, but that's a thing I learned over time.
What?
Back in the day when I did motherboards, pin 1 was the thing, the anchor you moved the thing with. But for pick and place machines, a lot of times they use the X, your center point of your package, as where the thing that picks up the part and puts it on the board. So for surface mount parts, you want that X exactly in the middle of the part where you want the thing to grab it. Yeah. So on this connector, since they're hand stuffed, it's not really a big deal, but
I don't like it when these are hand stuffed.
That's when there's 2.
No hand stuffing. Mark.
No hand stuffing?
No.
That's just saying.
Blackmail.
You can adjust. If you can go to a smaller grid and finesse that later.
Okay.
Right.
Sure.
So now put your LEDs near the edge where you want them there.
Yeah, I kind of can put them here.
Yeah, if they fit, do it. Yeah, give yourself just a little bit of buffer on the edge of the board because you're gonna need to pin those out.
Oh.
You can. That's on the under. You avoid the green pins, not the outline of the connector. So you can move that other one on the right in a little bit. There you go. Because you only have to avoid those green pins that go through.
Oh.
You don't have to avoid anything else.
Ah. Oh, can I make my grid smaller?
What's your grid?
1.
Do 0.5, so you're not so microscopic.
And then Alt.
If you want it even finer, then do 0.1.
That's probably...
Or set it to 1 and then 0.5 or something, or 0.1 if you want Alt control. That's really how you're supposed to use that anyway.
This should be good, I think.
At some point you want to do the ground plane and find out what the real edge is, because that may be less than the edge that you're allowed to use.
I'll move them. I'll do the ground plane next.
Just rough it in. Okay.
Raptor, like ground. Wait, oh god, where do I stick this?
That's your... You really boned yourself there.
Bone
you
yourself.
could move... I think you can plug... Is this cool? Yeah, the connector... See how on the side view? See the connector rides higher than the board? You can move that connector inland on the board a little bit, and you'll still be able to plug shit into it. So I would do that. Just back it. Yeah, there you go, until it clears.
Raptor. Raptor boards by Raptor. Oh god. Mark, am I good at this?
You're getting real good at it. You scare me.
Really?
You put me out of a job.
What?
And you're like, we hired this raptor. She can do a better job than you, Mark.
I'm like it, Blue Man.
And I'm like, what?
Raptor board making service. Do. Okay, so all my LRDs are in the LRD space. Yeah?
Yeah.
Okay, roughly. Except for this one. Can this go?
Oh.
Is this? But there's not going to be through hole things.
Yeah, there's
here.
some. See if it does it fit in there.
But this is on that thing's on the top and this thing's on the bottom. So.
Yeah, you're.
Or are those things through holes?
Those they don't poke through that much, but they need. Yeah, they're solder through holes, but it's a surface mount part. So if those blue pins don't collide with the green pins, you'd be fine.
How about this?
That's probably too ugly.
Okay, that's good enough. It's a heart.
All right, next thing you should do before you start to really do too much stuff is get your bypass caps close to the pins they need to be next to.
Bypass caps.
Add more bypass.
Burpass caps.
Bar parts. Or move your reset button where you think you'd want it. You want it in the center, bottom, or top.
Where do you want your nipple pressed?
You could put that behind the USB connector. You could put it.
I want it right here.
That sounds good.
Sure. Okay.
I hit your target.
Ooh. Ooh.
All right.
Big pin.
Where you want your programming thing? You want that hanging down?
Oh God. The pads?
The programmer ISP, CSP.
I don't have an edge of the board left to stick.
No, that's a through hole version.
Oh, okay, that's fine. Through hole is good.
I would put it below the reset button.
Okay. Where do I stick?
That goes near your power pin, so that's going to go up near the USB connector.
Okay, so this can go here.
I would not put that down next to the reset button.
Where's that? Here?
Down the one button you just did.
Oh.
You can put that above or below that, like reposition them. I'd put it below
here?
it. Well, do you want it to be symmetrical on the board, like artistically, or do you just want to throw it somewhere because you don't give a shit?
Mm-hmm.
Like,
can I do this?
Yes.
But I don't really use it. Okay, fuck it, there.
Or put it somewhere on the edge of the board.
Where do I put the fuse?
The fuse goes near the power.
And then this shit?
Those things are LEDs, so put them where you think an indicator would help you know what the F the board's doing.
You want to check the chat?
Yes, I want to check the chat.
Do you want to check the chat?
Tony signing off. Yeah.
Bye, Tony. I can say bye a million times. Sweet dreams.
Everybody's just fascinated with this. They're just watching. So.
Oh, okay. So that's everything. That's all
right.
this board is. I'm gonna give it worms now. Let's give it worms.
Okay.
Save.
No, get your bypass caps and that crystal oscillator where they need to be, because otherwise they're hard to place. So
these.
Yeah. So look in your schematic. Where do they go?
Wait. These are driving me crazy.
Turn your bottom off. Placement. Something to do with that. Dude, B place and B.
Am I not putting things on the bottom?
No, we're not. Or do you want your caps on the bottom? You can do that if you're gonna clean the board up. You're gonna put any decorations on the board?
Yeah.
Then yeah, put all your resistors and capacitors on the bottom. And the fuse as well, you may as well. Yeah.
Is the cap a big pimple?
It is high, yes.
Well,
it's a big dot. We can. Do we not need that? It's a nice insurance policy. I gotta think about that. You could add one and make it symmetrical on either side. Yeah.
Okay.
Why don't you put that in the hump of the heart?
I get nipples. The heart's gonna have poking
give it
nipples.
2 little nipple. You put little those stick-on eyes on the top of each one.
I'm gonna take some of those earplugs that I sleep in that are pink and put them on the caps.
So go in the schematic and copy that capacitor, and then put one on either side of the left and right.
Which is it?
It's the one that doesn't. It's a capacitor that doesn't look like all the others.
What?
The CAT. Right
This
there.
one?
Yes.
Okay. Okay.
Put it next to it. There you go. Okay.
Yay! Nipples.
So line those up, make them the same. You want to do it like that?
Wow.
Perfect. All right, so go look at your schematic.
Heart
All right.
nipples.
Find
Can I
out
name
what
them nips?
find out what those bypasses do.
Wait.
What?
This is important.
You need nips?
I need to name it.
Oh, nip 1 and nip 2.
Yeah. Yes.
Nip L, nip R.
Nip.
Nip A, nip
L.
B.
L. Nip.
If you lost all your audience. Oh.
Really?
Nobody's chatting. Anybody out there?
Wait, I can find out.
Anybody got any questions?
Ask Mark anything. There are 7 people watching now. And at most there were 12, and now there's 7.
Ask me about that time I met Ron Jeremy at midnight.
Yes, Mark met Ron Jeremy at midnight. Yeah?
Yeah.
Oh, the chat just updated.
Mine didn't. Is it updating?
Yes, Polisqualis is there.
Is here.
Some people are still sort of here, maybe.
Vibrate is watching.
Okay. Go. Okay. Done. Let's do this.
All right. We're supposed to look at your you keep ignoring me.
What?
Look at your bypass capacitors in the schematic.
Yes, they're here.
All right. You have 1, 2, and 3, 14, 15, and 16, right?
Yes.
So 1, 2, and 3 need to go near a power pin on your chip.
Okay.
So go back to your thing, and then look at one of the power pins there that they pin out to. That's probably where they're wiring off to.
Yes.
That's probably fine. Now position them either on the back or the front, sideways or rotated, but put them nearer to the chip. Yeah. What are you gonna do?
I'm gonna.
You're gonna put them at 45. You're gonna put them on the back.
Hang on.
You're gonna move everything to the back, right?
Yeah. Yeah.
All right. So pick up the group and then mirror it. So highlight it, move it, and then get it into move mode. And now hit the middle button. There you go. Are you gonna 45 it?
No.
You're gonna leave it. So go to angle 45.
Yeah, I know.
Right.
Is that the
Now make them one more. That's good. Now move it and line it up. Make the rat's nest kind of line up better. Move the group. There. See how that little, yeah.
there?
Move away just a little bit. Yeah, it's probably good. All right.
Okay.
All right. 14, 15, 17 or whatever it was.
Yes.
Same deal on the other side of the chip.
Okay. Oh god.
You can draw a box in there.
Really?
All 3.
Why wouldn't it let me make it?
Okay.
Whoa.
All right.
Wait, shouldn't they go there?
Are they specifically for that? I think that's just how they rat's nest. Oh, that's R54. Oh, go look in the thing again. What do those do? I don't think that's the ones. If we want 14, 15, and 16, we're going to regroup those.
Yes.
But if you go to the left a little more, you have R54, right?
Yes.
C17, and the reset. So R54 and 17 are going to group together and be near the reset pin, or anywhere on the board for that matter.
Okay.
Your R53, oh, that's right. We don't hook. A mistake I've been doing forever on these boards is I've been hooking a ref to VCC, and I just read recently you're not supposed to do that.
Don't do that.
So we can, so that we have a pad for it, unconnect VCC, delete the VCC on R53. All right, delete the wire, and then leave R53. So that way we have a pad if we want to solder to it for some reason. We have it there. So you're going to position R53 near that pin, right, on the back side of the board. You're going to take R54, 17, and you're going to group those near the pin 30 on the chip on the other side of the board. And then you're going to find C14, 15, and 16, group them together, and then put them on the others on the other edge of the board opposite of 1, 2, and 3. So you have C14, 15, right? Or 14 is there. Is it 14, 15, 16?
No, that's R54, C17, and C14.
No, but what was the 3? 14, 15, 16?
Yeah.
Okay, so grab 14 just by itself. Move. Oh, keep clicking. There you go. Right click. Oh, no. Because it's already smashed. Right click. There you go. Move it over. Yeah, so right about, just drop it there.
Okay.
All right, now find 15 and 16. Line them up. Yeah, there you go. And then. Oh, 16's up near that power connector. Right click.
Damn it.
Yeah, that's just how it is. All right. And then, yeah, get those. And then re-rat's nest. That's probably better. I think it was going the right direction. Right. Line them up, like, literally. If you have to type the value,
yes,
is get them all on the same y-axis. Yeah?
Yes.
Can you do that?
Yes.
Just zoom in. I think it's just that one, so just round the numbers in the properties. That's the actual, is that the chip or was that the, there you go. So make the Y all the same. So 38.5, 38.5, 38, 38, 38. All right, okay. That one, you see the X there?
Yes.
That means that one's rotated. So rotate C16 at 180. All right, now they're together. Now put them on the back side of the board and then run the wires in a fashion that lets you
be happy.
Be happy.
There.
All right, you're gonna 45 it?
Yeah.
You can change the angle right now up in the corner. Oh, hit enter. And then now the pins that you're going to go to is these two. So rotate it 190, 180, one more. There. See how they're normal now? So get them kind of in line. Go down. No, go under that. No, you're lining it up with these two.
Oh. There.
Perfect. There. All good. Since that one's smashed, just move that silk screen over. Just so you get it out of the way.
Ah.
Click it. Click the little plus. No, the plus for the silk screen. No, do you see where the silk screen plus is? So move that back. There you go. And then move it up to where it belongs. Is it not moving? There it goes.
Okay.
All right. Perfect. All right. Zoom out. What else we got? Any other stray thing? Oh, your crystal. So let's get that nailed down. So CR1. What is it? Rats 2. Okay, it goes there. So zoom in really good. you can mirror it and then make sure those 2 wires just come off the chip properly. There you go. The 2 pins you care about are the ones on the outside. The middle one is ground, and it's gonna rat's nest even though you don't care about the ground because take that. So you rotate it. That's what you want. Those 2 outside ones. A little closer. That's probably good. And then that's the reset ones, right?
Yeah.
So you're gonna rotate those 45 and move them somewhere on the chip, outside of the chip, or below the pins they go to. They're not critical because they're just a reset line, but right now, move group. Did you group them already? Yep. Do that.
What? Did they go here?
Handsome Rob was. I think Handsome Rob's asking me about my shirt.
Yeah.
My shirt yesterday was my Rush concert tour shirt, and Sarah and I had the pleasure of seeing Rush's second to last tour ever performance here in Las Vegas. The night after that was in LA, and then they don't do shows anymore. So we were happy to go see that. That was a fun night. And the cool thing was I got a friend who's an usher there, and when we got there, he moved us down right above the stage.
He had like front row seats.
We were looking down on Getty Lee. It was like
the best.
Amazing. And he gave me like a stack this high of beer tickets. And
we got trashed.
We got trashed.
It was fun.
Because beers are at the concert, they rip you off. They're like $12 a beer for a can of beer, like Coors or whatever. But so he hooked me up. So I'm forever grateful because that was like of all the concerts I ever wanted to see. I'm glad I got to see their second to last performance. So that was a good night.
We're so much the same, like I always hear.
Oh, that's cool. So Samuel, hello Samuel. Samuel says he does not follow most of this, to be honest. He's a novelist who loves some tech, and it's fascinating.
Cool.
So you're following in the footsteps of William Gibson, who wrote Neuromancer, because guess what? He didn't know a lot about tech either, but he's an awesome writer, and we love his books. So
pizza.
So yeah, so thank you for just watching us do circuit stuff. I hope it inspires you in your writing. It would be awesome.
Cool.
So
thank you for joining us
yes,
and being part of the board routing night party that is happening right now. Wait. Okay, let's do it. Let's start routing.
Yeah, they keep saying the on-screen chat doesn't update, so you have to flip back every minute or so.
Wait, so 43.
Samuel, he's really here for gripping social drama.
Ooh.
Do you want me to start yelling at Sarah or something?
83, 40.
Yell at me in German or something, right?
41.5.
What?
I'm centering things.
Are you moving things?
Yeah.
Oh, that's your
41.5. Oh wait, that was the no.
Oh, Handsome Rob says Sarah's shirt. Yesterday's shirt was the octopus.
The Soctopus.
The Soctopus. It's an
Yes.
octopi with socks. It's on woot.com, and you can probably still get one if you want.
It's a sock octopus. It's the best kind of octopus.
And
they
then
have
the one
socks.
you have now is your coffee raptors, right?
Yes, these are coffee dinosaurs,
Yeah,
which is the raptor.
When I see cool shirts on Woot, I get them for Sarah that I know she would like.
I'm an espresso raptor.
Yes.
That's me.
She's espresso raptor.
I'm a yellow raptor with the eye. I'm like, yeah. Chickens. Okay, wait. 50. Position 50. Okay. This one.
Is it high enough? Is it low? Do you like it where it's at? It feels low. Let's see.
Okay.
All right.
Properties. 50. Okay.
Okay.
Properties. 50. Just like Mark.
What? What does that even mean? Oh, my age.
Uh-huh.
Where's my age at?
What? Properties. 50. 50. They're all 50.
What are you setting to 50?
These things.
Oh, the center X.
Yes.
Okay.
That's what I'm doing.
Yes, things should always line up on circuit boards. It's just my opinion.
Ah. 25, 50, 75. And then it's 25. We'll just go with, sure, 58. There.
All right, now you got your the LEDs and resistors. Why don't you put one over each, the top of each capacitor?
Why can't I do that?
Is it not?
Okay.
Over or under?
I don't know.
All right.
Under?
Yeah.
What?
You have a heart for your heart.
I do. My heart has a heart, which is good. It's good when your heart
Yeah.
has multiple. Like my heart backpack has a heart, which has a heart. 3 hearts.
Yeah. Do the other one though.
What other what?
The power LED with the symbol.
Yes. Where does that go?
Put that on the, underneath the other capacitor.
What? Where does this need to go?
Underneath the other. Make it symmetrical. There's the LED on the left and LED on the right. No, over there. Way over there. Way up there.
What?
Over. Sorry.
What?
I'm putting it.
Where does it go?
Down. It's symmetrical with the other, just like the other one. The resistor and a capacitor, or resistor and an LED, right? Yeah.
Like this?
Yeah.
Okay.
You can either group them or you can make them symmetrical on your components. Yeah.
Okay. Should they go on the back?
Smashing.
Or...
Your resistor would go in back, but your LED you want on the top.
Okay.
It's an indicator.
Now what?
So, what's that stray capacitor next to the button?
Is this my fuse? Oh wait, this?
Yeah,
this isn't a resistor.
Oh, R53. Isn't that a pull-up resistor for? Oh, that's your analog thing. So move that next to its pin, yeah, and then rotate it in 45, and then put it on the backside or something.
Like that?
Yeah. Mirror. Mm-hmm. Mm-hmm. Rotate. That looks pretty good. Okay. Are you placed?
I don't want it to say controller.
I'll change its name.
I want it to say...
Dicks.
No. No. How do I do it?
Do the one down on the bottom.
What?
Just click name on the thing that has all the voltages on it. Bottom. There you go. Click on it. Name, and then click on it. Pizza. All right. Did the other ones rename to pizza? It's pizza.
It's pizza.
All right.
Pizza. Okay.
Make sure the other parts on your schematic actually change, since they're broken up.
Huh?
Did they change the pizza? They did. Okay. Pizza.
It's pizza.
All right.
Ah.
All right.
Okay.
Now you're going to start hooking up those wires.
Yay.
So you need to map these out. So starting at, let's say, the top.
Bat's nest.
All right.
No. Okay.
So starting near the top where pin 1 is,
Yes.
that's going to be on connector. What R is that? What's the connector name?
What?
What is that written? Oh, J what? No, upper left. Connector J10.
Yeah.
So you have those kind of going clockwise,
Yeah.
opposite the pin, so it's going to be kind of weird. Yeah, it'll probably be fine. Okay, so.
You're weird.
All right, so J10, you're going to pick 4 pins that are on the side of the chip that where pin 1 starts. Do you see that?
Yes.
So go look in the schematic and find a port that has pins 1, 2, 3, 4, 5, 6.
Oh, this?
Yes, that's going to wire to pins 1, 2, 3, 4, 5, 6, or
So these?
thereabouts. Yes, if you want a direct shot. And you're going to do them in the order so that you're not flipping them over each other.
Oh God, which was it?
Well, zoom in on the chip pins and find pin 1 or low numbers. Here we go, 2, 3, 4, 5, 6. So you're going to be hooking up to the PE, port PE.
Okay.
Right?
Yes.
And then the ones that are flagged are the ones that we verified.
Yeah,
that
Arduino Mega.
That Mega that the Leonardo. Or, yeah, you're right. The Arduino Mega uses.
Grab me a tissue.
And the ones that are not hooked up we know that Arduino Mega software doesn't support, so we're not going to hook anything up to those.
Deal.
Then you wouldn't be able to write anything for it. So.
Thank you.
So you have 4 pins, right?
Yes.
So you're going to use. Just go ahead and use D0, D1.
5,
2,
and 3.
Oh well, here's a thing to highlight. TXD0, that's the UART.
Okay, so
don't use those. We may use this for that one connector where it comes from your pizza board, your salmon.
Yeah.
But we may use one of the other serial ports for that, since we don't. If we do any debugging of this board, that's reserved for that purpose. For you to use the serial port command thing.
Yes.
So yeah, you want to kind of avoid
salmon
using that, and we'll need a connector for that too. So we'll figure that out.
Okay, so
so start with find pin 10. Maybe we'll ignore these for now. Find where pin 10 is. 10, 11, 12, 13 is being used. Well, no, in your schematic. It'd be nice to find 4 continuous pins for that port. You may not have used.
Here. Wait, that's analog. That's analog.
Oh, wait. What's analog?
These?
Well, that's 9091. No. On the chip, not the flags.
Oh.
The numbers next to them. Find 10. 10, 11, 12, 13, 14, 15.
Do you see them?
I'm not. It might be used for something else, but just go.
PG10? PG. I don't know.
I mean, it isn't 100% required.
I don't know what you're trying to
Oh, okay. Go down. 12. That's the ones. Go down more. G. It'll work. So you're going to use. It's just going to be weird.
I'm weird.
Actually, go back to the other pin. I want to see what those are called. Where we were PE. So we can't use 0 or 1, but there's D2, D3. Where's D4? Is D4 down in the other?
I don't know.
Scroll down to the back to port A or AK or whatever it's called. G. Is that D5? D4. Yeah, go ahead and use that. They're all close enough to each other. Yeah, you're doing Arduino mode. So go ahead and so hook up D2, 3, 4, and 5 to that connector.
Wait.
Oh, okay. Well, you're gonna do this in schematic. So flag on that J10. You see what I'm talking about?
No.
Go to J10.
Okay.
That is J10, right? No. Sorry, the connector called J10. Connector called J10. The connectors, not your chip.
Oh.
Just no, move. There. What's J10 there?
Oh God.
That
This
one down
one.
there. Okay. You sure you want to make them opposite like that?
Wait. I don't know.
Your connectors go counterclockwise in your numbering because of how you place them, and your chip goes.
It doesn't matter. Because once it's routed,
Whatever.
it doesn't matter.
Okay, it's hard to follow because you're doing two things in reverse like that for numbering and finding them.
Who cares?
I care.
Why? Once it's made, it just is a thing. It's a non-knowing.
The schematic process is a work of art, Sarah. The final thing means nothing to the world, but the schematic itself is a work of art in your heart. Okay, fine. Nobody understands what I'm doing. Okay, hook up D2, 3, 4, and 5 to 1, 2, 3, 4.
Wait, 1, 2, 3, 4. Is...
So flag those. Put the dots in the flags.
Yes.
All right, and then all right, so D2, D3, D4, D5.
What?
D2. Yes. D3.
Okay.
All right, go look at the board real quick and let's see how the rat's nest treated us. Yeah, it's for the most part
good.
But it's a straight shot, so at least your routing is going to be fairly easy.
Yeah.
So now for J9, is that J9? J2. I need zero all over the place. Whatever, like you don't care. Okay, so now find pins on the chip, right?
Is it J2?
Yeah, you didn't have...
Can I just rename them?
No, you can. So yes, that's the solution for
Okay.
that. Don't worry about it.
Jesus.
Well, perfection.
You can rename it. It's your universe.
I didn't think you would. You never. Okay.
So J2.
So go find pins on the left here. Mm-hmm. What pin numbers are those when you zoom way in? It'll show them on the pin pads. Go way in. There you go. They are
D53.
Oh, they give you the labels now. They didn't. My version doesn't have that because I have a really old version. So,
D53, D9, 8, 7, and 6.
Okay, 7, 8, 9.
Wait, so that one has...
Are they in order?
Yeah, so D53, D9, D8, and D7.
Okay, you need 4 pins. D53.
D53, D9, 8, and 7.
But see if you can get continuous numbers. So, please zoom back in. I'm going to talk to you. Okay, so 7, 8, 9, right? Mm-hmm. Is 10 here somewhere? Probably not. Yes, 10. So use those 4. Make them, because when you're programming, it's going to be easier for you to know that the 4 pins are the continuous, because D53 is like way out there. Okay. Like it'll just make programming easier. So go back in your schematic and then do 7, 8, 9, 10. And J2.
Everyone's asleep.
Yeah, everybody's going to bed. Or they're watching patiently. They're just listening. You don't have to say things,
They're listening to us argue. So 7, 8, 9, and 10 going from 1, 2, 3, 4?
Yes.
D, right?
D.
D7. D8. D9. Yes. And D10. Everyone's happy. Okay. Save.
Okay. Next one down. Mm-hmm. It's gonna go around the wheel, right?
Around the wheel.
So zoom way in and see what the signal's called. On
J3.
the corner of the chip, yeah.
So we've got 27, 28, 29,
And
and
these are not
26.
hooked up. So the ones that have a colon.
Yeah.
So 13.
D13.
Find 4 that go in
D49, D48, D47, and D46.
Yeah, do those.
So
And then
46 through 49.
Yeah, and then you can route them and flip them.
46 through 49. 46 through 49. Mm, mm, mm. D46, D47, D48, D49. Okay. Yeah?
Yeah.
But they're all crissy-crossy. So I should have
You
done the
can
opposite way.
uncross them when they get routed.
What do you
But
mean?
program-wise, they should go in the order you just did them. So don't worry about it. But they're still a straight shot over. So. What's the one that you plug into the salmon board? Which one was that?
Either J6 or J4 or J5.
All right, that one's definitely need a serial port because of what we did.
Yeah.
For that particular one.
I want potatoes.
So you need to get the COM one or whatever they call it on this. So
Potatoes.
let's find RX1 on this schematic.
Cake.
So that one's going to be special, and then choose which one you're going to use for that.
Okay. Wait, what do
What are the labels that you have on these?
I don't know.
Did you have a pelvis one?
What?
Did you have a label thing? Where's that chart?
Oh. This?
Stick to the chart. Yeah. Buns. Thigh. Pelvis. Oh, they're different. You have one coming straight off the bottom. So.
Yeah, it's not this one.
So pick one that you're definitely gonna use for the salmon,
pelvis?
and
Yeah.
rename the connector salmon or whatever, right?
Okay. He will be J5.
And we're gonna find the serial port for that and hook it up now so that we don't burn it up and then like regret later. Okay, now, so for Phileo, which is the bottom one?
Yes.
Not the butt. Do you have a button?
Yeah.
You want the butt to be the tip of the heart? No?
No. I want my front to be the tip.
That's true. I wasn't thinking right. What was that thinking? Anyways.
Naturally.
Yes. Okay, go in the schematic.
Wait, what? Buns. Pelvis.
It's
I might not even have buns. Yeah, I've gotta have buns.
like, what are you gonna wire into your buns? Like on your buns or in your buns?
Wait, let's name these.
You could have left bun and right bun.
Wait.
And thigh.
Front bun and back bun.
Wouldn't thighs be buns? Like technically.
Wait. Nips, neck, and head. I'm gonna name all these. This is important. This is really important.
Right.
Damn it.
Go ahead and get that out of the way.
Nips, neck, and head. Oh my god.
Vibrate took off. Sorry.
Good night.
Vibrate.
Good night. Nips.
Rob's still there. Pullis is enjoying our arguing.
Nips.
Pullis.
Neck. Head. Nips. Neck. I think neck and head can be.
And Samuel admires our work. He's really enamored by what we're doing. So cool.
Thank you. Thank you. Thank you. Oh.
Pullis says
thank
you're
you.
awesome.
What?
He says you're awesome.
No, I'm not. But thank you. Oh. Neck. Wait. Neck. Neck.
Neck.
Neck.
Neck.
Neck.
Scram and neck.
Neck. Head.
Head holdy piece.
Neck. Screm. Okay, neck. Head. Nips. That would be, oh god, J2 is going to be nips. J2, where are you? J2 is going to become nips. Ooh, it's done. We should
Wow,
change
those
it.
things go fast.
Nips.
That's because you're dual printing, aren't you?
Yes. Nips. Oh, okay, what else? Nips, neck, and head. Left and right arm, left and right thigh. I think arms J3 and J7 will be arms. J3. Left arm. J7 will be the right arm. Right arm. Okay. Left arm, right arm. Okay, and then I think, what the hell else do I have? Thighs. Okay. Left and right thigh should be J4 and J6. J4. Left thigh. And 6. Right thigh. Thigh. I don't know how to spell. And what's left? Buns and pelvis. Buns and pelvis. But really only buns. So I guess J8 is buns. It doesn't really want me to. Weird. Why? Yay, everything has been named. Phileo, thighs, arms, nips and buns. Nips and buns, head and neck. That's good enough. And the brain is pizza. I mean, that makes sense. Do. Pizza brain. Like the raptor. Okay. Everything's been named. I'm gonna continue finding pins for all of the things. Like left thigh is going to probably become
Oh, you need to do your
D45.
No, you need to find the serial port for your thing.
Oh.
And get so that we don't use it up and then have to reroute everything. All right, so go on your schematic, and then go to the chip. And we're gonna look for, I think it's RX1 and RX and TX1.
I don't see it. I don't think they
All right,
exist.
there's, well, that's TXD0. You're gonna look for TXD1. There it is.
Yeah.
So did we just use those? No, we didn't. D18. All right, so pins 45 and 46.
Yeah.
Right, and then you might as well grab 43, 44, 45, 46.
Mm-hmm.
Hook those up.
What?
To your
Phileo.
To the Phileo.
So which ones need to go where? Does it matter?
Just go do them in order. We'll work on it.
43 through 46.
Oh, that's right. They have a shit.
What?
Oh, and we're doing the reset pin on that thing too. Well, we can assert that. Okay. I don't know. We need to look at your schematic.
This is my schematic.
No, the Phileo schematic. Do you have a? You didn't print it, did you?
No.
No?
No.
Did you save?
Yeah.
Okay. Open the board up. Do like a screenshot of it.
Dicks.
Okay. Go find the serial connector. Zoom in on that with the chip and all that. No more. No more. Okay. No, the connector. J2. Yeah. All right. Get a screenshot of it. Okay. Go back to your board.
Yeah. Now what?
Samuel says you could make money by making a lapel pin version of his board.
Yeah.
A little tiny one. And that does your heartbeat.
Oh, that's good.
I was at a thing at MIT like 10 years ago, and they did that. They did a thing, and what made it notable is that Leonard Nimoy was the speaker.
Yeah.
They hired him to speak, and he. So the thing was a heartbeat sensor, right? And they had a woman come up, and he kissed her on stage, and then her heartbeat like pulsed, and that was part of the thing of measuring your body's like heartbeat and all that. But they made him kiss this complete stranger.
Oh. Aww.
He was a very good speaker.
I'm sure.
That guy was really smart. Anyways, but yes, a lapel pin would be awesome.
So, what do I do?
The
Raptor's tired.
All right. Yeah, you should probably wrap this soon.
But I haven't finished the board.
Okay, but you can finish it to do a double screen tomorrow. We've all got a screen tomorrow. Okay, so, all right. Where's the picture?
Oh.
Yeah, I get tired too.
Oh no.
Can you open it up and sort by time mode?
I don't know anything.
Do detail mode.
Wait.
The icon, there it is.
There.
All right, your. I could probably wire here. No, okay, we'll just cross it over. Okay, so your RX, right?
Yeah.
It connects to TX on the other thing, right?
Yeah.
So your pin 4. So pins 4 and 5 on the connector.
Yes.
So this connector. You know what? We can make the cable go the way we want it, since we're using different types of cable.
Yes.
So let's just hook it up normally.
Okay.
In your schematic, and when we make the cable, we'll refer to this and make the cable hook up to the pins the way we want.
Okay.
All right. So in this one, so just go ahead and wire those 4.
Which were they?
Those 4 things up.
These ones?
18, 19, 20, 21. Just wire them up the normal way.
18 through 21
Yes.
on this one?
Yes, 18 through 21.
Alrighty, adding tags. I'm so tired. 18. It's not even late yet. It's like not even 11.
What?
It's not even 11 yet.
It's almost 11. I'm definitely tired.
Damn. I don't know why I'm so sleepy. Whew. I had 2 martinis.
And 2 martinis.
Jeez.
All right.
Yeah.
do the next set over. So go look at your chip real close.
So close. Wait, I didn't do this one yet.
Well, that'll do this one then.
Okay, so
that one stole some pins, but that's fine.
45, 44, 43, and 42.
And guess what's on them?
What? Nothing.
Oh, is it the data? Was it the colon 45?
Yes.
I didn't see that.
I can't see that. 45, 44, 43, and 42.
Yes. That looks good.
Yeah. 42 through 45. Wait. Which one was that? 42 through 45, left thigh. 42 through 45. $43. Right, they're connected.
All gag.
But they're the reverse again.
That's okay. We want programming wise to make a sense, so we'll do it in the board. We'll reverse them. We have plenty of room to run vias and shit. So
okay,
it's gonna be awesome. All right,
you're bad.
Next.
Okay, right thigh.
Right thigh. What? Zoom in. What do you got?
Okay.
Yeah, start there, I guess.
41, 40.
What's on the corner over there? On the other corner, to the left. Is there any pins left over?
No, these ones aren't hooked up.
They're not hooked up. What's the one on the corner there, then?
38, 41, 40, 37, 36, 35, 34.
There's no 39?
No. 38, 38, 41, 40.
I mean, you can totally steal it from wherever it comes from.
37, 38. There's no 39. What the fuck?
It's somewhere else on the chip. So you can either take it from the chip and use those up and be efficient. Because you don't want to run out of pins and then have to redo this whole thing. So, that makes sense?
Yeah. I'm not gonna run out of
I
pins.
would try to use.
How about just the, like 38, 41, 40, and 37?
Well, when you're skipping, then when we're programming it, it's like you're skipping a pin. It's like it would work. It's just you're not sticking to.
I'm not using all the pins, so it's okay.
It's the programming wise. You're like, that pin skips one. Oh, I forgot. I programmed it wrong. And then why doesn't it work? So it's nice that they're always like what you expect. Believe me, when you're programming stuff and you do shit like that, you're going to be like, why didn't this work? It's like, oh, because I didn't read I totally assumed that they were all continuous. So find 39, go on the schematic, and find out where it goes. It may not be too far, and you just run it over. It totally tons of. I wouldn't look there. It's hard to read. Okay, keep looking.
This is 39.
All right, well, do that. So hook that up in the schematic. It's still on the same edge, so it's not a big deal. Totally do that.
39, 38, 38, 39, 40, and 41.
Is that okay?
So 38 through 41 goes to 38 through 41 goes to right thigh. I feel like I'm playing Twister.
Yeah.
38 through 49.
41.
41. 30. Shut up. Wait. What did I say?
38, 39, 40.
Oh god. Oh. Okay. D38. Sure. D39. D40. D41.
Yeah.
Okay. Right arm.
All right. What do you got over there?
Zoom
in on the chip.
I've got 37, 36, 35, and 34.
Perfect.
Okay. So 34 through 37, 34 through 37 on the right arm. Right arm, right arm, right arm. Okay. 34 through 37. See, this isn't so hard. D34. D35. D36. D37. Yeah. Hmm. Three more. Wait, two more.
You're almost there.
And I can route this and then I can go to bed.
Tomorrow you're gonna.
No, I'm gonna route this tonight.
No.
Yes.
No.
They're all going straight to the pin. It's gonna be easy.
You should route when you're fresh and.
No, I don't
tired.
want to be fresh.
Fine.
We're gonna do this tonight, and then I don't have to do it tomorrow.
Doesn't want to be fresh.
Salmon doesn't want to be fresh.
Nope.
The buns. The buns are gonna go to.
It's going to be fresh.
Those aren't hooked up. There's 4 on the end right here. 28, 27, 26, and 25. Yeah. Yeah? That's what it's gonna be. Wait. 29, 8, 7, and 6. How about that? Should I do these ones or these ones? 1, 2, 3, 4, or 1, 2, 3, 4? There's 5. Which 4 do I pick?
Oh, you gotta drop one?
No.
What's the lowest number one?
No.
And will it work in the next grouping?
25.
Yeah, pick the higher pins.
So 29 through 26.
Yes. And then maybe you'll use the other ones up on the other connector.
29 through 26 on the buns. 29 through 26 on the buns. 29 through 26 on the buns. Okay. One more. Those ones are also flipped. Mark, those ones are also reversed.
What? Did they flip over?
Mm-hmm.
You got so much room to run vias, it's not a huge deal. Don't worry about that.
Mm-hmm. Okay, so, and then this one is 25, 24, 23, and 22. Yep. 22. 22 on the neck. Neck. $22 on the neck. 22 on the neck. D22. D22. Yes. D24. And D25. Okay, done. Let's route this shit. Yeah.
My strategy is I would route straight off the chip until we got close to the connector, and then push and pop 1 or 2 vias to flip them over.
Push and pop.
Yeah?
Mm-hmm. Wait, I don't have ground planes.
Oh, do your ground planes. Well,
Wait. Draw a wire? Wait, how do I do this?
It's at the polygon box, the one next to it. Go ahead. You don't have to. Just note where you're. Make sure that's not above 100. Below 100. On that line. Oh, I guess it's already.
What?
Oh, it's still only at 80 high board. So it's not that has to be under 100. There you go. I don't use the tool with the right angle. See? Don't do that. Just Control Z it. You can wire the wire different ways. So first thing is change your grid to like 1 millimeter or 10 millimeters or something. There you go. Now, click the wire. Right click. Move the mouse. Right click. Right click. Right click. There. Now go to 100, 100. Or go to across. There you go. You can move it later. No, go back one. Is that inside the board? That's perfect. Now go back to 0. Okay. I'll use the name tool. Right, now do a red layer, same thing. That's what I see.
Okay, the grounds have been named. Yeah? See, there's not that much to route. I'm almost done. We can go to bed soon.
Yeah, so you're
I'm done. Done!
So on the top layer, route all your routes, and then you can do the power and stuff on the back layer.
Squiggles.
And then do your spaghettis. Now start with the chip.
Wait, I don't want it to be this small. How big should my routes be?
So you're going to go to mill mode. Do you want to be able to see the routes on the board?
I don't know. So how wide did I have them on the
minimum is 6, but 10 is a good number. And round vias, set those up, round, and then type 12 drill and hit enter. There you go.
Ah! Okay. Squigglers.
Oh God.
Heartworms. This is how you get them. Look, it's gonna go in. In.
Okay.
Everybody look at. That's how you get worms.
Yeah.
Into your chip. Chip worms. Oh God, what have I done? You have to really be good at this worming. Oh God. Oh man. Fuck. No. Mark, what do I do?
What? Well, end it early and then, yeah, go. Man, that's kind of knobby. Yeah. If he passes GRC, then go for it. There you go.
Shh.
I can't look this.
Shh. Watch, Mark. Open your eyes.
This is sacrilege.
Open your eyes to the sacred art of heartworms. Oh, that's not the right place.
Yeah, so you're gonna have to pop the. You can do it at the beginning, or you can do it at the end.
There, like this.
Well, no, you can't go across the chip. It's on the same layer. Yeah.
Oh.
So put a via, right? Actually, terminate it normally. No, go ahead and route it. Go route across the pins. I'm gonna show you a new trick.
No.
Yeah, go. Just do it like you would. Just hook it up. Don't care about where that you're crossing the pins.
I'm gonna go like this.
No, I was gonna. Do it. Smooth gig.
What?
I was gonna show you a trick, but no, go on the other side. You're on the bottom of the board. You can go over it now. You don't have to. There you go. That's too much. You have a thing in the middle of that. What's that LED? Let's come back to the top to terminate it. Right.
It's a game. Yeah? Squiggles. Oh, why does that have to be there? Why are these out of order? This is horrible. This is a horrible game. Mark.
What?
Oh. Why are you grunting?
Stuff.
Why are you stuff grunting?
I just love you.
Why?
I don't know. I really don't know. Take care of Raptor. The Raptor learned CAD and look what happened.
Thanks.
You crossed your bruisers.
What? Oh, shit.
You probably want to get to the bottom side and then track that. But watch those parts there. You need to get on the bottom side of those.
Oh, dear pizza. Shh. Don't mock the raptor.
Finally, a straight trace.
Shh. Do not. Do not the raptor mock. Mocking the raptor is bad.
Mocking the raptor?
No. Don't do it. No. Oh.
Check the comments. Anybody?
You are not disturbing me, Pulis.
So Samuel is logging off. Sorry to see you, Samuel.
Good night.
Hope we didn't miss you.
Sleep well. Dream of cake. Cake is the best kind of dream to have.
Pulis says you're playing Tron light cycles with electricity.
I am. That's how you do.
Pulis started playing music in the background just before you shushed, and he thought that you could hear his music.
And I was scalding.
And he jumped. He was like, "Oh God!"
No. Wait.
Good timing.
Wait, where does this go?
What?
Do I go around the blue pieces?
Where does the blue connect to?
I don't know.
Oh no, that's your VCC. Don't connect that.
I'm not.
No, don't. No. Don't do that one. No, that's a different route. That's a totally different layer. Don't do it.
Why?
No, it's VCC. Don't route Don't route pin 5 on any of the connectors. And do those later. Just the first 4 pins. Get those done. We'll figure the other stuff out later.
Fine. Why?
Because we're not just doing data right now.
I don't like this game.
Trust.
No. Are my nipples on the top or on the bottom?
Wouldn't you know, honey?
Nope.
Nips are on the left and right. Top and bottom. What nips?
Are they the top of the board or the bottom?
That's a top component.
Okay. Where do my nipples? Which way do my nipples
Which way
go?
do my nipples go?
Ask Tony. Oh God.
I'm gonna go to bed.
No.
I'm like tired, honey.
No.
Yeah?
No.
You're on your own. You're good.
Ugh.
I'm gonna go check out.
Why don't you love me?
Because I love sleeping.
Why? Oh, okay. Wait. No.
Wrap the stream up. Everybody's like logging off.
Okay.
Finish this up with more entertaining energy tomorrow.
I have entertaining
In
energy.
the middle of the day. I think you need to move the other end of that out more.
Heartworms.
Try the different modes. You just have it.
Oh God. This is hard.
Yes, you picked the hard thing to do. There you go. What? You can move those later. You don't have to do them in one shot.
It's important. Noodle says, "Mommy knows best." You don't question Mommy.
Don't question anything.
Noodle says you need to listen to what Mommy wants. She wants wiggler traces. Wigglers. It's super important. Okay, I'm gonna do this one, and it's gonna be the last one, and then I'm gonna go to bed, because I'm super tired. This is a lot of boards for one day. No. Oh. Oh God.
Yeah, you need to. Oh God. Yeah, I'm just gonna. That one gets special treatment.
Line it up. Noodle. There. Yes. This is an expression of how I feel right now.
That's gorgeous.
Beautiful. It's feelings.
It's how we feel.
Yes.
Wormy.
Wormy
Heart.
Heartworms are not meant to have any sort of...
Brandon says he likes that you asked, are my nipples on the top or the bottom?
Yes. They're sometimes on the top.
He says that's a weird thing to walk into. I guess he just joined.
Yes. The nipples are these yellow things, and they are on the top. See, there's a L nip and an R nip. See that?
Yes.
Okay. So the heart has... I guess they could be eyes. I could have called them heart eyes, but...
Yeah, I think nips are funny. So the heart has its own nipples.
They're the nipples of the
Everybody gets
heart.
nipples.
You
It's-
can milk the
it's
heart.
Nipple Day.
Milk
World Nip Day.
the heart.
Nips around the world.
Nips of the world.
Nips of the world. Nipcot Center.
I need midnight cheese. Nipcot.
Nipcot Center. It's like nipples around the world. Just nipples. No boobs, just nipples.
The heart only needs nipples.
Las Vegas Nipple Fest.
It needs tassels.
Yes.
I'm gonna put tassels on my
You
capacitors.
should totally.
And I can swing the heart like this and they're gonna go.
Oh.
Yeah.
Yes, inside the bag.
Should I
Inside
put
the backpack.
should I put pasties over the capacitors?
I think tassels would be funny.
Capacitor tassels. I need to market those. Do your bypass caps need tassels?
Yes. they
Marks
do.
do. Marks do.
You can't have too many tassels.
Alright.
All right, you gonna wrap it?
I'm gonna wrap it. Guys, thank you for keeping me company while we do this
Yeah, it
board
was-
routing endeavor. I'm gonna probably
Chat was fun.
it's been fun chatting and making heart worms with you. I'm gonna probably finish this tomorrow. And then I'm gonna unwrap that roll of red vinyl and look at it, and I might stream the whole thing. So more work on the heart tomorrow, starting in the daytime. So, yeah, different energy.
Yes.
And Mark won't be here. He's gonna be
I gotta work.
doing work. So it'll just be
Work.
Sarah.
Works in quotes. Work.
You know, work. Mark's good at
I love
working.
my job.
He's good at
I'm
it.
gonna work.
All right, guys. I'm gonna click over to the chat and look at your lovely faces one more time. All right. Good night, guys.
Good night.
I love you guys. Sleep well. Dream of
Nipples.
noodle.
Noodle and nipples.
Noodle.
Just dream of nipples.
Dream of either or both. I don't know. Have fun. And I'll see you, I don't know, tomorrow.
Yep.
Wait. I gotta find it. Stop streaming.